So good morning. Good morning. That's better, that's better. Welcome to the second edition of Leaders in AppSec. We have a jam-packed, pardon the pun, jam-packed event for you this morning, where it'll be kicked off by Matias Madou, I think the whole theme around today's Leaders in AppSec is security awareness and the unconsidered values that is tied to security awareness and how we can actually change culture within the organization, a positive change. It'll be kicked off by Matias, who will go through his keynote, around 30 minutes, around going through his experience in AppSec and how security awareness is helping organizations and how he's done it in the past. Then we'll move swiftly on to and get some insights from Sam, the OWASP London leader, followed by our panel. And I suppose the whole premise behind Leaders in AppSec, well, I think it's safe to say we're in the fourth industrial revolution. Everything is powered by technology. I'm sure we've all heard that a bank is a technology house now with just a fancy balance sheet. And with the advancement in technologies like cloud computing, edge computing, infrastructure service, and dare I say it, quantum computing, it makes our life a bit harder. We have to keep pace with the innovation. Technology is keeping pace with technology. But at the heart of the solution, how we're going to scale AppSec is via people. And the whole premise behind Leaders in AppSec is to connect people in the industry, leaders that are driving strategy and execution within their organization, or future leaders, to collaborate, share insight and best practices in order to drive the next wave of AppSec. So it's great to have you all here today, and really looking forward to the event. So our first speaker, Matias. I was going to stick to script, Matias, and do an official introduction, but I'm going to give you my version of Matias. No, I won't embarrass him. So I've had the pleasure of working with Matias for the last 3 years. Matias was one of the starting engineers at Fortify, has a PhD in AppSec, and is Secure Code Warrior CTO and co-founder. So I think the CV speaks for itself. But also, Matias, some unknown facts. How many goats have you? How many chickens have you?
I have 3 goats.
3 goats.
Maybe more next year.
Maybe more. Depends on Christmas. But also, Matias holds 11 patents.
Yeah, yes, I do.
11, and I'm still trying to get to the bottom of all those.
Yeah, sure.
But let's kick things off. Matias is going to go through the unconsidered needs of security awareness programs, share some insight and best practices based on his experience. So Matias.
Thank you very much, Sean. Really appreciate the introduction. Next time I'll introduce you, and I'll get some hidden facts about you. So welcome everybody. Really appreciate the big turnout at this time of the day. I once gave a presentation in Istanbul, and I had to give that presentation at 9, and I was there at 8:30, and there was absolutely nobody there. And they were even questioning why I was there. They said, come back by 10, and there's going to be a session at 10:30. So really appreciate you coming out this early in the day. Today I would like to talk about, hey, the people behind the bits, the people that are writing the code. How can we help them these days? How can we empower them to write better code? And why is that beneficial for the entire organization? A pretty full agenda that I'll try to get through. I'll do some introduction about myself, about Secure Code Warrior, the state of the software security, application skills shortage. There's still a big shortage, and it's ever growing, and what we can do about that. Security and development, normally there's always some tension between security and development, and I'm trying to get to the bottom why that really is and what we can do to help. And then security awareness. How can we bring security awareness in the organization? How can we change the organization so that everybody rallies behind the same vision and make sure that we all write secure code from the start? So who am I? Thanks for the introduction. I'll do the official one then. Started my career at Ghent University out of Belgium, pursued a PhD in application security where I was working on static analysis for code obfuscation, so mingling applications, making sure you no longer know what the code is doing internally, but it still has the same functionality. With my PhD, I moved to the US, joined an at that time small company called Fortify, was one of their first researchers working on static analysis, trying to find problems in code, and I actually stayed on for 7 years. And in these 7 years, I've learned a ton of things. But at the end of the 7th year, I actually learned 2 things which made me jump ship and start this thing. Which is, first of all, I think it's not really hard to find problems in code if you never tell a developer how to code securely in the first place. So it's like asking people to make a race bike, and once it's done, you say, well, now I'm going to try to steal it. Well, of course, you will be able to do that. So Fortify, I think or static analysis in general, I think it's a really good way to find problems in code. But of course, make sure that these people are trained in the first place, that they know what to do and how to deliver code in the first place. And that was one of my major eye openings when I was at Fortify. So Secure Code Warrior, started Secure Code Warrior, and the entire premise was like, hey, how can we help the developer? How can we do something more positive? How can we not slam the developer with problems afterwards? How can we help him throughout his journey in writing code? So the state of security, let's start. I'm a numbers guy, you know. I always like numbers. 1 in 3 of the newly scanned applications had SQL injection. I have a question for the AppSec people in the room. So how many? So first of all, AppSec people. Who's AppSec in the room? Okay, fair amount. Who is like 100% certain that you do not have SQL injection in your applications? Yeah, so everybody has a database, right? Yeah, you do. Okay, that's unfortunate. So 1 in 3, and actually I think that's very realistic. If I see scans, if I'm dragged into a room and they say, hey, look at our code and let us know what we should focus on, well, it's quite often SQL injection. And if there's no SQL injection, quite often they do not have a database. They just scan an application which doesn't have a database. Yes, these applications exist. It's an old problem, SQL injection, 20 years old. Quick story, when we were decorating our office, I had an XKCD with SQL injection. There's an XKCD SQL injection. The frame was very interesting, but when I turned the frame, it was actually signed by my manager at that time, which was Jacob from Jacob West at Fortify. And that thing was 10 years old. So 10 years ago, I was at Fortify. We were working on finding SQL injection. And 20 years ago, if you look it up, 20 years ago was the first instance where people discovered SQL injection. And here we are, 20 years later, we're still talking about SQL injection. And if I ask the guys, you know, are you confident there's no SQL injection? Nobody can, you know, we're very uncomfortable saying, you know, our applications do not have SQL injection. So it is still a hot and burning thing today, unfortunately. 111 billion lines of code. Who's developer in here? Developers? Quick question for you guys. Are you going to write more code next year or less code? Less code? Then you're one of the few people that going to refactor your applications and do better. But if you look at, simple example, Windows, Microsoft Windows, it's always more code. You know, if you look at every application out there, we want to make new features. We want to produce more code. So it's an ever-growing thing. And as Sean rightfully mentioned, everything is running on code. Our planes, even our fridge these days, our coffee makers are running on code. And code is one thing, but people no longer think about the chips they put into these machines. Chips are so cheap. So they no longer think like, what is the minimal set of things that thing should do. No, they just take a chip which is way too powerful and they let the machines do things. And well, guess what? These machines do way more things than you anticipate they can actually do, and they get hacked and they turn into bots. So there's definitely a discrepancy between, you know, the number of lines of code and also the chips that we're using for the purpose that it should serve these days. Application security, security in general, building code, building applications, it's very much like building a house. If you build a new house and you're entirely done and after the fact you realize that you have like faulty wires, well, it takes a lot of money to redo that, and the same is true with code. Although I think, I was thinking about this one this morning, and I think it's not entirely true because this is a new house, and quite often we're not constructing new houses anymore, you know. We get a lot of legacy stuff given to us that we have to make secure. And I think a better analogy that I was thinking about this morning is I actually bought a farm, the farm of my grandparents, and they kept it up to date. They remodeled it along the way, and they kept it up to date. And when I moved in, I realized the bathroom was still outside. And I said, you know what, I want to get that inside. But for them, they were like, but why? You know, why? This functionally it works. Just, you know, go outside. But it's super cold in winter. But they're like, functionally it's correct. And we're actually the same with legacy code. Functionally it works. If you go to your developer and you say, change that, because we know it's 20 years old, but right now it has a security problem. They're like, why? It functionally works. Look, I can do all the things that it is supposed to do. Why should I change that? So I think that's the same kind of thing that we're running into day to day with our developers and AppSec between developers. What does it cost to fix problems in code? This is the only actual piece of data that I found on the web. It's about Jim Routh from Aetna. He actually did the test. He went into his organization, figured out how much he was paying for tools, and figured out how much they were costing him to fix problems in code along the way. Okay, I think it's slightly outdated because the new way of doing is more CI/CD and ship with confidence and rapid feedback cycles. So it's slightly outdated, but it gives you a good idea of you know, it costs more along the track. You know, the longer you wait in fixing problems, the more it's going to cost. For him, for example, it was 14K when he found a problem in testing, maintenance. To maintain the code, when he was finding a problem over there, he knew if he wanted to fix that, it was going to cost him 14K. That is when you fix problems along the way, you would say that's a high cost. Well, the real cost is you know, make sure that you can fix problems earlier. Another piece of research was that, hey, if you fix it in the IDE, it is 30 times less expensive than fixing it later on in your code. The real problem over here that I see is junior people coming on board, they want to do the right thing, and they look into code what actually works. And it's a very similar analogy like with the house. They look into code and they figure out, oh, over here I have some working piece of code, let's copy paste that into my code and make sure that it works for my piece over here. This may be not the best code from a security perspective where he found that particular piece of code, but it's not exploitable. But if he drags it into his code, you actually have the copy-paste problem where the other person used concatenation. Well, it actually works. He copies it into his code. It uses concatenation, but then suddenly it becomes a security problem. So the developer should be guided, especially juniors should be guided in making sure that they are armed with tools, with training to make sure that they can really figure out like, hey, what is good code, what is secure code, and do that in the IDE. So we really want to make sure that he gets the tools, get the guidelines and the knowledge to write the code securely from the IDE. That is his starting point. If you do that, fantastic. If you don't do that, what is the cost of a breach? I do not want to go into details of here. On average, it's 3.86 million, and it rises over time. Sony is a notorious one on the list. They are notorious for not doing the right thing in the old days. These were actually SQL injection problems, but there were way more problems than only SQL injection. The initial entry point was SQL injection, but then they actually stole an Excel sheet with all the usernames and passwords. So that is what it can roughly cost you if you have a breach. One thing I would like to say is, what I found interesting about that is if you look at the wiki page of SQL injection, they kept it up to date on public breaches. And at a certain point in time, the person just stopped keeping that up to date because there were so many publicly disclosed breaches on SQL injection that the person maintaining that page just gave up. He said, you know what, it's forever and ever. The AppSec skill shortage. I'm happy to see already a good chunk of application security people versus developers. I think it's a reality that, think about you as an AppSec person, the couple people that are here that are AppSec, how many developers do you have versus the number of application security people? Think about that. Do you guide 10 developers? Most likely not. You know, it's going to be more than 10. Do you guide 50 developers? Well, if you guide 50 developers, you're actually in a good state. You're doing better than market average. In general, we think that you're gonna roughly guide 100 developers, okay? So if you're in that ballpark, you're average. If you think about your organization and you have 1,000 developers and you're the only AppSec person, well, that is very, very unfortunate. I hope you can get some more budget because then you're really, really understaffed. But think about that number. Think about 100. That is the average. Think about 100 people. Did you speak to 100 people this week? Did you speak to 100 people in your organization in general? 100 people is a lot of people. In this room, I'm not sure how many we are over here, but can you speak to everybody like today and guide everybody today and this week and next month and forever and ever? It's going to be really, really, really hard to guide 100 people. Okay. Where does that number come from? If you look at BSIM, they say building security and maturity. It's a maturity model. Well, over there, they say you roughly have 2 AppSec people per 100 developers. But the study is done on companies that already care about application security. So the number is, in my mind, a little bit skewed because these are companies that already care about application security. Not all organizations care about application security. So if you don't care, you will definitely not be into that study. So it's definitely less than 2, okay? It's virtually impossible to guide 100 developers. I think we can all agree on that. And the problem is this thing is becoming more and more a problem. I actually had a good chat right before the meeting, before the event over here, and finding talent is so super hard. It is so super hard. And Cybersecurity Ventures, they predict that we will have 3.5 million unfilled roles. So for the people over here, not a lot of students over here, but if you're looking for a career opportunity, I would say like go into AppSec cybersecurity. There's definitely career opportunity. At the same time, the problem is rising. You know, 6 trillion globally that we're gonna be able to, in cybercrime activities, 6 trillion, that is just gigantic. And I think this is gonna be even more problematic, let's say if there would be an economic downturn, it's gonna be even more problematic. More people will be forced into cybercrime and we will not be able to keep up. So how can we actually fix that problem? How can we think about that problem? How can we consider a solution for that problem? Well, think about your developers. Your developers are writing the code. It's them that are writing the code, right? AppSec is just helping them out and making sure that they are guided and write secure code. But it's still the developer. The developer writes the bits and bytes. Okay, so and they are eager to learn. They are quite often eager to learn. They want to do the right thing. So maybe it's a good idea to see how we can engage the developers from the start and make sure that they help us out in this entire battle. But let's have a quick look at developers and how they see today application security and security in general. If we look at companies out there in the AppSec market today, they all say, you know what, we have to fix things faster. We have to find the problems faster. And even in these words, there's already a problem because they're talking about finding problems faster. They talk about fixing faster, which means there are already problems. They're not talking about proactively trying to make sure that you guide a developer in writing secure code. So there's already that negativity into the message that they're giving. They're trying to come closer to the developer. They want to, well, help the developer, but in a fairly negative way, because, you know, we're going to tell you the problem and we're going to make sure that you can fix it faster. Or, well, there's going to be a rapid feedback cycle so that you get the problems back faster, you know. So all the traditional AppSec companies, they still have a fairly negative way of looking at things. They want to come closer to the developer, but in a fairly negative way. They just do the same thing over and over, but just faster. That's essentially the whole set. So, I'm actually convinced that that is not the right way of doing it. You know, there should be a positive message towards developers. We should help the developer. We should tell them how to do the right things from the start and not slam them constantly with problems. Let's figure out how people talk or not talk to each other. actually for developers in AppSec. Are there developers here together with your AppSec counterpart? No. That's what I guessed, you know. Well, you know, there's this natural tendency between developers and AppSec. You do not come together to events like that, right? Builders, the developers, you know, they really care about their code. Normally, the way you roll into writing code is, well, you already have a hobby which is called programming, and then suddenly you realize there's some university study that you can take, and you can actually take your hobby to your professional career. That's how a lot of people turn into developers. They love writing code from the start, you know. And they care about their code. They consider it their baby. They're super proud of what they're doing. They come to work with, you know what, I'm gonna make this, it's gonna be awesome, it's gonna be great. They love what they're doing. They write something that they are very proud of. They consider it their baby. Breakers, it's actually a very similar path. They break stuff from a young age on. They decompose stuff, they look into stuff, and they wanna break it. They can see if they can make it do things that it was not supposed to do. And then they figure out there's a professional career, and they can get some certifications on how to become, for example, a professional pen tester. And they go into that. And they love breaking things and telling people how they broke these things. If you put them together in an organization, that's fireworks, right? You know, these guys, they come in quite often and they tell the other guys that their baby is ugly, and they actually give a deck of 100 pages how ugly that baby is. And they do not really tell the developers how to fix the problems. They just tell you it's super ugly. I'm not sure how you're gonna fix it because I do not know enough about your code, and they leave. So if this is the way you start, you know, that's not a good way to start, you know. It's just because we're speaking different languages. Both have valid points, by the way. I'm not saying or arguing they do not have valid points, but based on their background, they are very, very different. I've also already talked about, you know, the old days of working where you waterfall-wise work on code, and ultimately people are going to look into the security of that code. There's definitely the new way of doing things. When pen testers come in these days and they make a report, well, normally the developers are already way ahead, and they say, you know what you've tested is a week old. We're 10 versions later or 100 versions later because we constantly ship code. So we also have to adapt to this new world, this whole CI/CD, DevOps, DevSecOps. There's a lot of names out there, but we really have to adapt our tools or think about new tools that can integrate into our new way of working. So let's figure out how we can transform this entire set of problems into something that we can be proud of and look forward to into our own organization. How can we be more positive? How can we focus more on the people in our organization? How can we rally everybody behind the same vision that, you know what, we want to do the right thing for our organization, and let's all work together. So what I would like to go through is first of all the focus. Let's figure out the focus. How can we build practical knowledge and skills? How can we bridge that gap? How can we make sure they kind of start to talk the same language? And how can this all be enjoyable? You know, there's definitely a new wave of learning things which is more gamified, more interactive, more enjoyable for everybody. Developers. If I look at developers, if I look at my own developers, they really like. I'm located in Bruges. I'm in the Bruges office. If I look at my developers, they really want to do the right thing. They're super eager to learn. They want to do the right thing, but they do not know how. They do not know, like, can somebody guide me? How can I do the right thing? I want to do the right thing, but who can I ask? You know, they're eager to learn. They're creative. They're problem solvers. They all have these really good qualities. And again, focus on the people. If we can engage them for security, that would be fantastic, right? It's only a matter of working with them and steering them into the right direction so they can get that same energy, not only for development, but also for secure development. How we do that today? How do we work today with developers and security in general? Well, they are developers, they write code, they check it into a repository, which eventually get built, we deploy it, and it's in production. Today, I would say 90% of the AppSec market focuses on the right-hand side. SAST solution, static analysis solution, so you do not execute the code, you just look at the code and you try to find problems in code. It's like manually going into the code, but the SAST solution just collects the knowledge of a lot of people and get that into a tool. laest solution comes, I would say, very close to debuggers. You kind of run parts of the application and you try to find security problems in there, mainly used with the QA department. So you run applications, but you look for problems in code. RASP, again, a technology, runtime application security. It sits in the production server itself. It's some sort of an agent that can stop bad things from happening. It's like a firewall, but from within your application. And DAST, dynamic application security, it's treating your application as a black box and just shooting out attack vectors and see what happens. Technology, 90% technology. 90% of everything is really technology. And they try to come closer to the developer, but in a fairly negative way, finding the problem faster. Or you can actually focus on the developer itself, the person, the human that writes. These are all bits, by the way. Again, bits on bits. We're trying to defend bits with another layer of bits, but all these bits are written by developers. So let's focus on what the developer can really do. The developer, we can engage him through tournaments, through training, and through coaching, through assessment. We can help him. We can tell him how to do the right thing from the start. So we really want to focus more on the prevention side, working with the person and see how he can actually improve his skill and over time make sure that he can also teach other people how to write secure code and help other people with their problems. So instead of one person trying to guide 100 people, let's see if we can get a couple people engaged, and these people are going to engage more people, and ultimately you have an entire team that rallies behind writing secure code. So let's talk about a blueprint for a secure coding program. You crawl first, you walk, and then you run. Let's start with the crawling phase. If you want to do something like that, you really have to understand your developers. Where are your developers? What's the culture in your organization? What's the culture in the countries? If you're a global company, you have to figure out, like, how can I deal with developers, for me personally, then in Bruges, but also in Sydney, and maybe into the US. Very different culture. Although we try to have one culture across the globe, there's still very much differences in these offices. What are they working on? Is it Java? Is it .NET? Is it COBOL? What does their sprint cycle look like? Like, when are they super busy and you should not interrupt them, or are they going to really be mad at you because you're interrupting them in some highly creative work? Or when do they have downtime, like right after a release, a successful release? Quite often they have some downtime. So maybe we can work our way in there and schedule some time in there that they can get something creative done, and from a training perspective, and get that going in a downtime period. So the crawl phase is really a discovery phase. Also, who are the stakeholders in your organization? Can I work with these stakeholders? How do I work with these stakeholders? And you actually start to build out a plan. What do I want to focus on? Is my problem, do I have a database? Well, maybe we should focus on SQL injection. Or do we have a static analysis scan or a pen test report? What should we focus on? So then the walk phase is you build out that plan and you work with the stakeholders. You validate with the stakeholders. You even work with a small team, like 10 people if you're a 100 people company, or 100 people if you're a 1,000 people company. So you work with a small development team and you try it out. You roll your solution out. You roll, for example, a training out, and you say, hey, you know what? Give us feedback. Does it work? Does it work for you? Does it fit with your flow? Do we not interrupt your day-to-day work? You work with a small team, but you think globally. You really think globally. You think about a theme that you can roll out, that people can rally behind. You think about the communication plan that is globally. And once you find an initial fit with a very small team, you launch a global campaign. You launch a global campaign to rally the entire organization, and then you're in the run phase to rally the entire organization around the same vision, around the same goal, that, hey, you know what? As a company, we want to do better. We want to write secure code from the start. You roll it out globally, but very important, figure out where the pain points are. Don't look at your of course, you look at the things that you achieve, but mainly focus on the things that do not work. Why is a certain team not picking it up? Is it a different culture? Did we miss something? Because that is going to be key. Focus on the things that do not work. And in the run phase, that is very, very important. You make sure there's enough communication. Why are things not working? Try to adjust things to make it work for that particular team. Because that is going to ultimately be what you're going to report back onto the stakeholders. You know, where were you successful? Where were you not successful? And what did you do to actually achieve success globally? You want to have a scalable program, a global program. So that's how we see it. You start with some discovery, and ultimately you roll it out globally. First thing you need to do is figure out what the goal is for your organization. And in general, we see like 3 major topics. It can be either awareness, you know, you want to do that across your employees. You want to make the entire organization more security savvy. Well, in that scenario, what you really want to do is you want to give something relevant to your developers. So you want to do awareness across all the employees. But for your developers, you really want to give them something that resonates with them, something very specific to their day-to-day job. Or you just want to give them training. Quite often, there's a training budget in organizations where they say, you know what, and especially like if I look at my developers, they tell me, you know, give me something interesting. I want to learn. I want to be better at my job. You know, for junior people, they say, you know what, where should I look to go to the next level? How can I upskill myself? And in that perspective, you can give them the option to do training. You know, give them some relevant training, or skill verification. And over there, what I quite often see is there's definitely a relation between a very good developer and a security savvy developer. There's you know, I've never came across a really good developer that said, you know what, I don't care about security. That's you know, that's not my thing. There's always a very, very tight relationship between a security savvy developer and a really good developer that wants to learn, that wants to know more, that wants to do better. And for them, it's really important that they can expose their skill and also guide other people, but also get some recognition. So they want to do it in some sort of skill verification. They want to make sure they are recognized. So make a blueprint. Make a blueprint. On the left-hand side, you figure out who are my developers, where are my developers, what is their sprint cycle that they're working on, what are the languages, or not even spoken languages, but also programming languages. You take some lessons from the past. What are my lessons learned? What did not work? What did work? And you adjust. And what is my desired outcome? So I have goals, priorities, and success metrics. To give one example, you can say, well, I have to do this for PCI compliancy. That you know, it sucks, but at the same time, you know what? Let's make it something meaningful for our developers. So let's focus on very specific vulnerabilities. Let's look at scans that I've done, and let's figure out the vulnerabilities that I really, really care about, and let's focus on that. And ultimately, well, initially you can say, well, I care about how many people are on the platform, how many minutes do they play, and so on and so forth. So really basic metrics around the platform itself. But ultimately, that is not your goal. Your goal is not making sure that everybody is on the platform and everybody plays 2 hours a month, for example. That is not your goal. That cannot be your goal. Your goal should be, do I see a reduction in vulnerabilities? If my pen testers come back in, is my code more secure? That is ultimately your goal. So you can start with some basic metrics around the platform itself, but ultimately your goal should be, what does my result of a pen test say? Is it better or worse? You know, that is a real objective. So your blueprint, it starts with a security champion. You make sure that you identify them. A developer champion, it is really a person in your development organization. You're only one person, 100 developers. You need more help. Identify these people. Figure out who can help you. Figure out who's strong and has an interest from a development perspective into helping you out. It's skill, but it's also communication. So you cannot say, well, I'm gonna only take the best developers. Well, that person has to have more than only be a top-notch developer. He has to be a good communicator, or it's not going to work. And then you actually can roll a program out the way we are successful within organizations is, you start with a tournament, you get everybody engaged, you make it fun, people compete against each other. Out of that tournament, you identify your security champions. But also out of that exercise, you know what they know and what they don't know, so that if you roll out a training program, you focus on what they don't know. If they work a lot with databases and you see across the board that nobody has ever heard about SQL injection, probably you should focus on that. So you get some hands-on training, really code specific. But ultimately, it can be all fun and games, but ultimately you have to prove that they are improving. You can do that through scans, through comparing static analysis results, through comparing pen test results. But another way of doing that is assessments. You give out an assessment and you figure out if they really improved. How good are they right now? And you get some baseline of, hey, within my organization, they know about certain things, they do not know about certain things. And you reiterate through your training program, you optimize your training program, so you ultimately achieve your goal. I think I already mentioned that communication is absolutely key. Without communication, it's not gonna fly. Think globally. Think about the entire organization. Think about the mechanisms that work in your organization. Is it Slack, or is it blog post, or is it something else? And use that. It depends on the culture of your organization, but really make sure that you have a good communication plan that taps into what the developers are already doing. My developers do not read email, for example. They don't read email. You can send them emails. If you don't do it via Slack, they're going to ignore you. So if you only do it via email and your developers are not reading email, you have a problem. I already mentioned that. Measure the impact. Initially figure out how many people are on board, but measure the impact of your training program. Don't try to put your security head aside and think about your developer. What does your developer care about? Does he care about, learning on his own in a gamified and fun environment, hands-on, something that is relevant for him? Think about that. Think about the developer first. Don't think about security first. Think about the developer first, and then weave security in there. If you want to know more about this, you can actually read up on a couple case studies on our website. The first one is from IAG. They really wanted to upskill their developers. They thought about Game of Thrones, and they modified Game of Thrones to Game of Codes, and they got that entire theme out, and they had like a really good buzz within their organization. And actually that went really, really well. So if you want to know more, like how can you, a real example, how you can transform a theme into something that works within your organization, that is a good example. Another example is a tier 1 US financial. Over there they said, hey, you know what, we want to generally upskill our developers. And they said, hey, you know what, let's do it in bits. Every day they have to take 3 to 5 minutes to do one challenge in the platform, meaning they only had to do one training module, a very small training module, but every day for 3 months. And they saw in general a big increase in their security posture. They could verify that through external metrics like pen tests, like static analysis solutions. They could verify that externally. So what are the key takeaways? 30 times more expensive to fix something late in the development lifecycle. If you can get the guidance with the developer in the IDE, that is really the place you have to be. You really have to think about the developer first. Don't think about security first. Think about the developer. How can this work for the developer? And then overlay security into what the developer is already doing. Make sure you have a clear goal and clear priorities in mind, which makes sense, not ticking the box. If you just want to tick the box, it's not going to work. Think about, what would I really like to achieve? Focus on one particular vulnerability, for example. Focus on the positive, not on the negative. Don't focus on, we're going to slam you with a lot more work. These developers already have a job. They need to write functional code. They have deadlines. You don't have to give them a second job, which is, security. No, think about something positive that weaves in with their day-to-day work. Empower them. Figure out who can help you in these teams. Figure out where are your security champions, who is a good communicator that can get this going into your organization, work with them, and ultimately look at the result. Look at your end result, which is better code.